This is Course 3 Math, Lesson 8-7, using graphs and tables to solve linear equations, and I am Mrs. McCowan. Today you will be learning how to use graphs and tables to solve linear equations. Our vocabulary words are systems of equations. This is a set of two or more equations that contain two or more variables. Solution of a system of equations is a set of values that are solutions of all the equations. Example number 1. A fishing boat leaves the harbor traveling east at 16 knots nautical miles per hour. After it travels 40 nautical miles, a Coast Guard cutter follows the boat traveling at 26 knots. After how many hours will the Coast Guard cutter catch up with the fishing boat? So we're going to let T equal time in hours. We're going to let D equal distance in nautical miles. So if it's traveling 16 plus 40, the distance equals 26 times t. So we're going to graph the equation. And if I graph this, I have the fishing boat and then I have the Coast Guard cutter, and they should be crossing at 105 distance, which is about 104 on 104 right there. And so the point appears to be 404. So they catch up after 4 hours. Check it out. A machine starts producing 50 widgets per hour. After it produces 50 widgets, another machine starts producing 75 widgets per hour. After how many hours will the machine have produced the same number of widgets? Well, machine 1 would have been W widgets equals 50 times H plus 50. And then machine 2 would have been widgets equals 75 times H. So it appears that the point of intersection is 250. And if I put that into my equation, 150 equals 50 times 2, which is 100. 100 plus 50 is 150. And 150 equals 75 times 2, so that's checks. So when they're both at, let's see, that would be 175, 50. And then the other one would be at 100, 150. Then they would cross their paths. Question number 2. Solve each linear system by graphing. Check your answer. So for letter A, we're going to solve both equations for y. So I'm going to solve by isolating the y and getting rid of 3x. Well, to get rid of positive 3x, I must subtract. So I subtract minus 3x from one side. Whenever I do to one side, I do to the other, so minus 3x from the other side. So my equation now reads y equals negative 3x plus 3. So I'm done. Both my equations are in y equals mx plus b mode. So now I can graph. So if I graph my line, when I put in 1 times 2 minus 7 is negative 5, so that would be 1, negative 5. When I put in 3, 6 minus 7 is negative 1. And then my next equation, I had 3, so I put in 0, it is here, 0, 3, and then put in 1, and then I get 1, 0. And then when I put in 2, so it appears they intersect at 2, negative 3. And when I do this, I get negative 3, 2, negative 3 equals negative 3, so that checks. 2, negative 3, 3, 3, that checks. Letter B. So we're going to solve both equations for y again. So this one, I have to move my 2x over to the other side, so I subtract. So now I have negative 2x plus 9. Now I have to move my 9 over to the other side, so plus 9, plus 9. So now I have negative 2x plus 9. Hey, wait a minute. This equals this. That's true. So we know that if I were to add 2x to the other side, that 9 equals 9 is always true. So that the lines are the same. So we know that it is infinitely many solutions because it's the same line. So if I were to graph this, I would graph at 0, 9. And then when I put in 1 for x, I get negative 2 plus 9, which is 7. So we're going down. So I have infinite number of choices. Okay, try 2A and 2B. Check it out on your own. Okay, 2A, we should have gotten that the solution appears to be negative 2, 9. And then when you graphed your lines, they should have crossed right here. So you had one slightly like this and one slightly like that. The next one, it was the same line, so you should have had y equals negative 1/3 x minus 2, so they have infinitely many solutions. So there was not just 1 point, all points were the same. Do you need extra help? You can go back and watch the video again, ask Mrs. McCown a question, or come in the morning for extra tutoring. Thanks for watching.